Hello, good morning. I'm discussing about application of common ion effect. Common ion effect is mostly applied in salt analysis, that is qualitative analysis of basic radicals in group surfacing. When a strong analyte having the common ions added to the solution dissociation of weak electrolyte is suppressed, that is decreased to a desired extent. Consequently, the conditions are created when one cation is selectively precipitated but other remains dissolved in solution. Precipitation of group first metal ions for basic radicals. Group first metal ions are mercury, silver, lead. When hydrochloric acid is added, it is uh, precipitated as chlorides. Silver chloride, mercury chloride, lead chloride. Solid product of chlorides is a very low in comparison of chlorides of basic radicals of other groups. These low solubility products are easily exceeded by the ionic products, hence metal ions easily precipitate on addition of dilute hydrochloric acid. Precipitation of group second metal ions, metal ions, mercury second, copper plus, titanium +2, cadmium +2, arsenic, stibnum, and bismuth. In this precipitation, the hydrogen sulfide is added. It is precipitated as sulfides. For example, cuprous sulfide. If the hydrogen sulfide is only passed through the solution, the ionic products of corresponding metal ions and the sulfides ions not only exceed the solubility product of group third B, and acidified with hydrochloric acid, H2S is passed through the solution. HCl is strong electrolyte and produces large number of hydrogen ions. H2S is weak electrolyte, which produce small amounts of H plus ions. Due to the common ion effect, the hydrogen sulfide is suppressed. At this time, ionic product is sufficient to exceed the solubility product of group second metals, but not for okay. Okay, solubility product of group second metals, but not for the group third B metals. So that metal ions of group second are precipitated as sulfide, but metal ions of group third B are not precipitated even and they are present in the solution. Precipitation of group third A metal ions, iron, aluminum, and chromium with uh, third positive charge, precipitate as the hydroxide solubility product of group third A metal ions. If only the ammonium hydroxide is added to the solution, the ionic product of corresponding metal ions, hydroxide, not only exceed the group third A, but also exceeds the solubility product of group third B. Okay, in order to avoid the precipitation of group third B, along the group third A, ammonium hydroxide is added in presence of ammonium chloride. Ammonium chloride is the strong electrolyte and reduce the large number of ammonium ions, produce the large number of ammonium ions in solution. But the ammonium hydroxide is a weak electrolyte which produces least number of ammonium ions in the solution. A dissociation of ammonium hydroxide is suppressed very much due to the common ion effect. In this condition, ionic product is just sufficient. In the decision of ammonia hydroxide of risk very much due to common ion effect. So, in this condition, ionic product is the just sufficient. However, ammonium hydroxide is the weak electrolyte which produces less number of amino ions in solution. Dissociation is suppressed very much due to the common ion effect. In this condition, ionic product is just sufficient exceed the solubility product of group 3A metal ions. Precipitation of group 3B metal ions. Group 3B metal ions are zinc, cobalt, nickel, manganese, precipitated sulfide, ammonium hydroxide, ammonium chloride in S2S. S2S is dissociated hydrogen ion plus sulfide ions, and zinc, if zinc salt, it is the zinc sulfide hydrogen ions, and ammonium hydroxide and ammonium ions, water. H, the H plus ions are consumed by which more H2S molecules dissociate to produce the sulfide ions. As the concentration of sulfide ion increases, the ionic product of sulfide of group 3B metal ion concentration increases.